A very good morning to Madam and my fellow friends. Today, our group CAA are going to present a project titled Counter Design. First of all, I'm going to introduce myself and my members. My name is CHEAH EC21032, and my other member is No Anis ATHIRAH BINTI AZHARI, EC21013, SITI AININ SOFIA BINTI MOHAMMAD ROSDI, EC21018. Due to the changing in the technology era, we have to follow the pace of the technology goal because technology brings convenience to community. There are so many applications such as calculator, traffic light, digital watches, and cellular phone require digital electronic to function. In this project, we are required to design a 4-bit synchronous counter using JK flip-flop that count in a unique sequence from 0, 2, 4, 6, 8, 10, 12, 14, and simulate our design using multisim to show the numbers by connecting 4-bit synchronous counter to the 7-segment display. At the same time, undefined numbers which is 1, 3, 5, 7, 9, 11, 13, 15 were required to return to 10. A synchronous counter can be different type based on their design. Based on our project, the 4-bit synchronous counter is considered as a synchronous up counter and begin counting up using even number. One of the components that we use in our project is BCT to 7-segment. In driving a 7-segment LED display and provide a convenient way of displaying digital data in the form of numbers. JK flip-flop. There are 4 JK flip-flops that trigger by clock signal positive going transition is implemented in design 4-bit synchronous counter. The inputs will not affect the queue until a positive going transition is occurred. The 4-bit synchronous counter is a sequential logic circuit that consists of a cascaded arrangement of 4 JK flip-flops. The clock input of all the flip-flops are connected together and create the same clock signal at the same time. As all flip-flops change state simultaneously, the total propagation delay will be the same for any number of flip-flops. The objective for our project is to design a 4-bit synchronous counter using JK flip-flop and connect it to the BCT to 7-segment decoder to display specific numbers such as 0, 2, 4, 6, 8, 10, 12, and 14. And we also have to stimulate the design with simulated software such as multisim to display the output to the 7-segment display.
Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. My name is Nur Anis ATHIRAH binti AZHARI and my matric number is EC21013. Today I would like to explain about the method in our project. There are 7 steps in our method. So the first step is state diagram. Design number of bits is 4, so we need 4 flip-flops to allow counter to count from 0 until 15. So yang berada kat dalam kotak macam seperti bulatan tu adalah design number, manakala yang berada di luar, nombor yang berada di luar kotak tu adalah undesigned number. So step yang kedua adalah develop a excitation table for bit synchronous counter. Yang saya tunjuk ni adalah basic saja untuk control input JK flip-flop. Dan ini adalah table, excitation table daripada refer daripada state diagram yang kita buat tadi. So step yang ketiga adalah simplify J dan K using KMAP. KMAP ni function dia adalah untuk simplify expression for all control inputs. Dia akan refer daripada excitation table tadi. So kat sini ada 8 KMAP sebab berdasarkan 4 bits, so mesti ada 8 KMAP. Dan juga step yang keempat adalah logic expression daripada kita dapat logic expression ni daripada KMAP yang kita buat. Kita develop from the KMAP to make a conventional logic circuit. Dan step yang kelima adalah logic circuit. Ini disebabkan ada 4-bit synchronous counter, so kita akan buat dalam circuit tersebut akan ada 4 juga JK flip-flop. Jadi output yang akan berada dalam JK flip-flop adalah Q1, Q2, Q3 and Q4 dan juga Q0 1, Q0 2, Q0 3 and Q0 4 yang akan berada dalam output JK flip-flop. Manakala input dia adalah based on logic expression yang kita dapat tadi. So bila kita dapat logic expression 8, maka akan ada 8 input untuk circuit yang akan kita bina. Antaranya ini 1, 2, 3 dan 4, manakala ini pula. So ada 8 totalnya.
Next, we will proceed to the simulation of the project as well as operation of the system. So first I will list down all the components that we use in the circuit. First, 4-channel oscilloscope, 4 probes, and then we have JK flip-flop, and then we have IC 74LS47D, and then we use N and OR gate, and then clock voltage, and then a ground, and then interactive digital constant and VC. And then this is a 7-segment display. So first, I will explain how I connect all the JK flip-flop. Okay, so after the calculation and the CAMAP that we did, we got JA is equal to 0. So we connect it to the interactive digital constant 0. So for KA, we got KA is equal to 1. So we connect it to the interactive digital constant 1. So for JB, also the same for KA, we connect it to the interactive digital constant 1. For KB, we got KB is equal to A0. So we connect it to the A0 input. And then for the JC, we got A0B. So here we will use AND gate. One leg we connect it to the A0 input, and then the other leg we connect it to the B input. Okay. So for KC, we got A plus B. So we will use OR gate here. This is the OR gate that we use. One leg we connect it to the A input, and then the other leg we connect it to the B input. Okay, so for JD, we got A plus BC. So here we will use 2 gate, which is one OR gate, and then the other one is AND gate. So first, we use AND gate. So the AND gate, we will connect it the other leg with C input here, and then the other leg we connect it to the B input, and then the output line we will connect it to the other leg from OR gate, and then the other one we connect it to the A input here, and then we connect it to the JD. Okay, so for KD we got A0 BC. So here we will use 2N. Okay, 2N gate. So here from the previous JD, we will use the same AND gate, and then this output will connect it to the one leg from the second AND gate, and then the other one leg we will connect it to the A0 input. So we got A0 BC, and then we will connect it to the KD. So that's all for JK connection. So for IC 74LS47D, this BCD to 7 segment decoder have 4 input line A, B, C, and D. So this line we will connect it to the each input A, B, C, and D, and then the other for the right side we have 7 output line A, B, C, D, E, F, and G. This 7 segment we will connect it to the 7 segment display. Okay, and then these 3 line we will combine it, and we will connect it to the VCC here. And then for the last line, ground line, we will connect it to the ground, and then this line we will connect it to the VCC source here. Okay, so for this 7 segment display, for the top one we will connect it to the VCC, and then for channel oscilloscope, we have 4 channel, and for A, B, C, and D channel, we connect it to each input with the same object. objective here. So for at the right side, we have G, so we will connect it to the ground here. Okay, so that's all for how I connect all the circuit. And then for the probe, we will connect it to each input A, B, C, and D. So next, for the simulation of the circuit, I will run the circuit. You can see that it will display the sequence number 0, 2, 4, 6, 8, 10, 12, 14, 0, and then it will repeat. And then for the simulation of the output waveform, I will double click here. And then we will see the output waveform here. Notice that this input have a different color. For A input, I set it as dark blue. For B, green. For C, orange. For D, turquoise. Okay. We can see from this output waveform, we can see the changing state of each input. The system output only can change a state when the clock makes a transition. For JK flip-flop, clock input is activated only when a positive going transition occurs. From this screen, this is the PGT, positive going transition. This is the cell, and then this is the channel. We can change the channel anytime. That's all for the simulation of the circuit. I think that's all. Thank you.
Okay, we will continue about the discussion based on our result analysis. In this project, we aim to give an overview of the 4-bit synchronous counter. We had implemented a 4-bit synchronous counter using JK flip-flop, which was done using the Multisim software. After making the circuit of JK flip-flop, the circuit diagram was individually run to make sure that the respectively achieved timing diagram perfectly matches with the corresponding truth table or not. Then the synchronous counter follow a predetermined sequence of the state in response to the command clock signal, advancing one state of each pulse. In the end, a correct figure of our timing diagram for the 4-bit synchronous counter was obtained. However, when the circuit diagram of the 4-bit synchronous counter was implemented, some errors in the output timing diagram were observed. The circuit can display the output, which is what our project need, but undesired number didn't display at the output. We try to recognize the troubleshoot on the circuit. Lastly, we assume that undesired number that returned to number 10 is unused state. So the unused state will not display on the LED. That's why our undesired number did not display on LED.
Conclusion is, to design a counter that count in the unit sequence, we must decode the various state of the counter using combination of logic circuit. After that, we must supply proper logic circuit to each J and K input at the same time. Other than that, it's better to use synchronous counter rather than asynchronous counter, as asynchronous counter have propagation delay. Hence, the more the number of flip-flops in the asynchronous counter, the slower it will be. Our group has successfully to design a 4-bit synchronous counter using JK flip-flop and connect it to the BCD to 7-segment decoder. As we still made our design in Multisim, it able to display the numbers 0, 2, 4, 6, 8, 10, 12, 14 through 7-segment display. However, the undesired number 1, 3, 5, 7, 9, 11, 13, 15 were not able to display number of 10. Thus, we assume the undesired number are unused state, which will not display in the 7-segment display. The difficulty in facing this project is the simulation, the design, and the display problem. The solution is we try and error until got the right answer and do the research in the internet through YouTube and refer to lecturer notes. The precaution that we have to take note is ensure that all the input for all the flip-flops is correct. And it is very important for the connection of the counters in correct manner so that the hexadecimal display show correct reading. Thank you.